Hello, this is the third homework for the algorithm design and analysis. The topic is master theorem and recurrence relation. I'm starting with the master theorem application question solving. For the first question let's take the first question from the ChatGPT and then also I wrote a little bit cheat sheet in here, and it gives the question. Consider the divide conquer algorithm that divides a problem size n into two subproblems, each size n2. Okay, we can write it like n divided by 2 and problem size n into two subproblems and two subproblems here. And algorithm combines the solution of problems on time plus on, and you have the following recurrence relation for the algorithm time complexity. Actually, yeah, okay. So it gives me in here. Use the master theorem to determine the asymptotic bigger time complexity of this algorithm. State the solution and which case of the master theorem you applied. Okay. Or a is equal to 2 and b equal 2 and d equal 1 in here, because n in this n 1 over n power 1. So if we compare a with b over d, it will equal to 2 equal 2 power 1. So we have to use this one, and to using this one here, or n over dad is equal 1 and log n. So our algorithm time complexity is equal to o n log n. And let's ask the question, or is it true or not? I found it like this. Is it true? You are so close, it appears, but you mean error in your answer. The correct solution is n log n, but you didn't specify which case of the master theorem you applied. And you can apply master theorem in this case to master theorem. Actually, I did it, but I didn't write to ChatGPT. And yeah, let's put it. I make it this way. And the approach are correct. You correctly identify the values for A, B, and C. Applied case to the theorem. Your calculation equal log 2 to n equal 1. Since C equals 1, the time complexity indeed or n power c log n, which simplifies or log n log n. So both approach and final answer are accurate. Well done. Let's take the second question. Oh, sorry. Algorithm device. Yeah. I want to do it like this one. And let's say problem size and 3 subproblems, each size and 3. Okay, Tn equal 3 power t and divided 3 plus subproblems n power 2 time, or n power 2 time master theorem asymptotic big O time complexity of this algorithm, and same. In here, or a is equal 3, b equal 3, and d equal 2. If you compare a to b power d, it will equal 3, and 3 power 2, it will like this one. So we have to check a less than b power d, and we have to use this one in here, and or tn is equal to o n power d. So our answer is o n 2, or n power 2. Let's ask the, is it true? Is it true? Is right check, but let me clarify the case of the master theorem you should apply. Okay, as we did, b time complexity b over d log n, and no, I'm sorry, I'm checking the wrong place. It's here b over d. So you should case one master theorem b over d. Yeah, it's the true. And let's ask the third question. And can you give me the hard practice question on master theorem? Yeah, okay, it's giving me here. Device problem size and each size. Okay, let's start to write in here. Okay, t and divided 4, and common solution. Okay, and that's twice problem, and 4 sub problems. So it must be 4, and plus again bigger of and power 2. And you have to follow the recurrence relation for this algorithm time complex. Use a master theorem to determine the asymptotic big O time complex of this algorithm. And okay, let's do it. A equal 4, b equal 4, sorry, and or d is equal to 2. So if we compare it, a equal 4 and b over d will equal to 16. So a less than b power d again. So we have to use it. We have to use again this algorithm. And let me copy paste in here. Yeah. So or tn is equal to tn equal or big O n power d. So or n power 2. Let's ask the ChatGPT. Is my solution true? Your analysis is close, but there's a small error in your application of the master theorem. Where did I wrong? In your case, and T2, you have correct item had the equal one. When A is equal to B power D, you should apply case 2. Actually, it is not equal. Did I say equal? No, I haven't seen any equivalency. Secure, but you should include the algorithm factor of case 2 for that. What? Am I making any mistakes? A equal to A less than B power D, and when A less than B power D, I have to use N power D. In my case, A less than B power D, so shouldn't I use to or, N power D? Yeah, okay. I apologize for any confusion in my previous response. You're correct. Actually, here okay, it's a mistake of the ChatGPT actually, and in your case that means complexity. Yeah, okay. Actually, there shouldn't be any n. So the answer is n power 2. I want to ask it again. So yeah, okay. It gives the answer is your initial solution of OF and power D is indeed accurate. I apologize for any provision confusion and appreciate your patience. Okay, we are continuing with the second chapter of the homework with the recurrence relations. Relations, and I wrote here a little bit cheat sheet for me, and let's ask the question for it. Let's take the question from ChatGPT, and here our recurrence relation. Given following recurrence relation for algorithm time complexity, and t n equal t n divided 2 plus 1. Actually, I wrote here the time complexity of it must be log 2n, but let's solve it again. Okay, and t1 equal 1. If we go with the t2, it will equal to t2 divided by 2 plus 1, and so it's equal t of 2 and t of 1 plus 1. So t1 equal to 1, then 1 plus 1, so or 2 of t of 2 equal to 2. I will not try to solve this question with the t of 3. I will go into the t of 4, and it will go t of 4 divided 2 plus 1. So t 4 divided 2 equal to t of 2, and then our solution will become to t of 2 plus 1. So the answer is for the t of 4 will equal to 3. Let me write again here. I will not try the others one. I will go into the t of 8, and it will become t 8 divided by 2 plus 1, and again it will equal t of 4 plus 1. So the answer is 4. Let me write here again, t of 8 equal 4. And let's go to here. Let's see. And t of 1 was equal to 1. They are going one by one, and here's actually t of 1. We can write it like t of 2 power 0 equal to 1, and t of 2 equal to t over t power 1 equal to 2, and t of 4 2 power 2 equal to t, oh sorry, actually I should write it like this one, 2 power 2 equal 3. So it will going to t n power 2, and it's going with this one, and it will must be equal to O log 2 bases n. For the computer so actually for the algorithm designers, we can take log 2n. We can assume every log n is same as log 2 bases n. And let's ask is it true? I solve it like this. Is it true? Right track back seems the slightly misunderstanding you were determining the complexity. Let's clarify the correct answer. And however, interpretation not occur. And you can observe the pattern that each step Cn divided by 2. So you add 1. So number 2 determined by the log 2 n. Log n is correct. So it's just important to express as it's as a function of n is log n in this case. Yeah, actually I made a mistake in I couldn't see what you want to say. Yeah, actually I could be said wrong in this way, but my algorithm is true anyway. Actually I stopped the recording because I couldn't explain what I wanted to say, and I think a little bit about it, and it want to say you should I shouldn't express it in terms of with a value of like t of 1, t of 2, or t of 4. I have to just express in the t of n, and it just want to explain. So sorry for the confusion, and let's continue with the second question and see. Let's take the second question from the ChatGPT. Okay. Medium level. Given following the recurrence algorithm time complexity. Okay. Actually I can copy and paste. It will be faster. Which the base of t1 again. t1 equal 1. Determine the time complexity of the closed form expressed for tn. Okay. Okay, let's go. And if you write it in 2 in here, actually it will go same as always dividing by the 2. So we can express it like 2 power 0 or 2 power 1 to 2 power 3, etc. And for the second one, 2 times t 2 times t 2 divided by 2 plus, or n is 2 right now, so we should write in here. So 2 times t of 1 plus 2. So t of 1 is 2, 4, and the answer will be 6. T of 2 is equal to 6. And if we go to the 2 of 4, it will give the answer like, it will be always times with the 2 times, and t 4 divided by 2 plus n and in this case, or n is equal to 4. So 2 times t2 plus 4, or t2 was equal to 6, so it will equal to 16. And let's write t of 8, and it will equal to 2 times t 8 divided by 2 plus 8. So 2 times t4, 32, and it will be equal to 40. So how we can write it? T of n is equal to, for the 2 n divided by 2, we can write actually log n, and always multiply by 2. So 2 multiply log n plus n. Actually, we can give it like this one. And let me ask to ChatGPT. This is my solution. Is it true? Almost correct, but there's a small typo. The correct time complexity of O(n) log n plus 2, but is written as O(n) log n plus n rather than O(n). Your final answer is O(n) log n plus 2. Actually, it's always dividing by 2, so it shouldn't be wrong. But yeah, let me ask. But there is 2, not 10. I apologize for the oversight in my previous response. You are correct. The recurrence relation is 2n 2 times n divided by plus 1. When you solve the recurrence relation using the master theorem, you will find the time complexity is indeed O(n) log n. Your original solution occur O(n) log n, but actually I wrote in here plus 1 to. I might be solve it wrong, so I'm gonna stop the recording, and I will try to understand what it's saying. Then I will start the recording again. After this, I understand my mistake. I just write t of n equal to O 2 times log m plus n, but the unnecessary part is 2 times. Actually, it's also equal to O log n plus n, log base of the 2. So I ask the question again with 1 by 1, and I understand it why I made a mistake. So we can continue with the third example. Must be third, isn't it? And yeah, let me take the question from ChatGPT. And this is the question. And let's take it from here. And t of 1 base case is equal to 1. Determine the time complexity of algorithm and find the closure form expression for t of n. And okay, let's continue with this one. 1 equal to 1, t2 equal to 2 times t1 plus 2 over 2, and t of 4 equal to 2 times t2 plus 2 over, 4 over 2. So, and let me write 8, 2 times t of 4 plus 8 over 2. Okay, so 2 of n is equal to O notation, and 2 times, for this one must be log n, log n, of course log 2 base n plus n over 2. So this is also actually equal to log n plus n over 2. So let's ask the ChatGPT, is it true? I found it like this. Is it true? On the right track, but there's a small error in the final step. Okay. N over 2 times log n. Actually, there is a simplifying y. The master terms. Yeah, okay. I haven't used the master theorem in here. We can actually. Time complexity indeed on over p plus log n. Your original scenario up to this point, however, your final step has a minor mistake. The time complexity is n log n, not all. Master solution should be as one. Let's ask like this one. This is the algorithm, and there is not 2 times and divided 2 and over 2, not multiply them. You're correct, the recurrence relation, and the terms are summed, not multiplied. There's a correct answer, and when I be the usual case to term time complex, then applies an earlier confusion for a pressure. If you solve it like this one, okay, let me try to solve it this one, or a equal to 2, b equal 2, and d equal 2. Actually, a less than b power d, and must be shoot this one, as we can see. So Tn equal to n over 2. There's not a algorithm. Actually, if I solve it in master theorem, answer will be n power 2. Actually, for the algorithm, there's a log n plus n over 2. We can write it like o log n plus n over 2. So we can ignore the o can ignorable to o log n. So answer is o n power of 2. Actually, this is must be answer. I solved wrong in the first time. I log n could be ignorable. So let's ask it again. Let me do it like this one. And where's my, yeah, okay. For this question, I found it, and let's copy and paste it in here. Is it true? And ask it, is it true? Not correct. Not quite correct. Let's go through the solution together. Recurrence. Master theorem. Okay. And n. You should get its complexity n over d plus log n. So recurrence relation to time complexity and log n. Next occur dominant term of the complexity and over log n is negligible for compression and over 2. It's still given the n over 2 times log n. So let me check for a moment did I make any mistake. Then I'm gonna start the recording again. After this, I understand why I made a mistake on question 3. I forgot to ignoring all log n before the asking to answer is true or not. And for the and ChatGPT is a little bit confused me. And I asked the question why you multiply O of n power to n to O log n. There's no multiplication, there's only summation. And it gives me this answer. So in this case, the dominant term is O of n power to n O log n is relatively smaller, so you can simplify it to O of n power 2. Therefore, the correct answer is indeed T of n equals to O of n power 2. And thanks for the listening. Have a good day.